Abdullah, please.
Yes, thank you. The second work is the also numerical simulation. It is soil structure interaction, means soil concrete foundation interaction, and the work made based on the theoretical concept. And we use our guess to apply and show how the soil concrete foundation interaction will be made and what we can get from this output. Here we have a lot of the infrastructure made suspect to the earthquake, suspicion to the earthquake. But we don't know what will be happen. Based on what we present here, we can predict the stability of the infrastructure and we can assume the structure will be safe or not. This motivation of this work and the methodology is the our guess and numerical simulation, and the material we use what was reported in literature. At the end, we come to the result, discussion, and the conclusion. If we come to the free field, you can find after earthquake, number of the crack may will be occur on the field. And what we want to understand from this, here assume in this kind of the crack or this kind of the settlement, we construct an infrastructure, at least road or building. In that case, at the first point, we can find the road is part two part, and if in the building, it will be affected to the structural element in form of the crack or may damage. Then the theory we use here, the simple theory is reported in the literature. It has three direction, means horizontal, vertical, and rotation of the force. And the same we apply the force to simulate of the foundation. What assumption we have here? We have a rigid concrete foundation and flexible and deformable soil is rest on the rigid base soil. Then what force we applied here? We applied force in two directions, the acceleration in the X and the Y, based on the recording in the literature. From this paper, we use this data and they use the theory, and from here we use the soil material. At the end of the motivation, we come here, methodology, we came to the numerical simulation and the material. We use two types of the soil foundation. The first dimension of both are same, but different between the first and second is, here we added one more concrete foundation. It's here. We have two concrete foundation rest on soil, but embedded in the soil foundation, and here is three. And which place we apply X and Y acceleration. For each one, from number one, we use this point and this point for the reference point in our case, and here also set 1, 2, and 3. Then the work was based on the 2D finite element modeling, and we came out with the maximum displacement in number 1 and 2. The type of the material we use here both are same, and the force we applied here also is same, and the X and Y direction. But we can find the differential settlement in both cases it not be same. It's due to the adding a new foundation here. If we come to the stress, we have same. Second part, we have the also strain. And what we can get from here, and what displacement is important here. Most of the case, the low displacement here is very important in all design of the structure, but here what we have, the displacement on the base means from here up to here. We use point by point, node by node, to draw this kind of the graph, means the distance from 0 up to the 6. Then, when we have here the model 1 and the model 2. In the model 1, we have 2 points, and the model 3, and we have 3 points. What we can understand, when the number of the foundation is increased, the differential settlement also is increased. When we have 2, the differential settlement, it will be less. Then at the force, what we have the force. In the model 1, we can apply more load with the lowering displacement. This is logic and it is acceptable. Then what we can understand from here, we get 3 points of the conclusion. It's my conclusion, and where we can use this kind of the word, we can use for prediction of any constructed structure based on this method. Thank you so much.